Hi everyone, good afternoon. My name is Krishna. So today's session is confusion matrix in machine learning. So before this, you need to have little basics on machine learning. So before we start on machine learning and all that, I'll just give you an agenda of today's topic. It's like we are going to talk about the need for a confusion matrix, what basically it is. And we will discuss two examples, if I remember, on the PPT. And we will understand different metrics that are useful to assess how good the model is on different parameters. And finally, we will understand confusion matrix can be applied on what are the different types of classes it can be applied, whether it can be applied for a binary class, multi-class, and all that. And we will understand the key things or key features of confusion matrix at the end. So before we start on confusion matrix, I'll just tell you, when you say machine learning, there are certain things you need to understand. So what exactly is machine learning? So machine learning is actually, if I put it in a very, very technical terms, it is nothing but a set of algorithms which help a machine or a program to learn by itself without human intervention. Which means, let's say today when you write a program, any program you write, you actually code it in such a way so that it takes an input, process it, and gives the output. So the processing part, if you see, it's not going to change because that's what you have coded and it still remains the same. You give different inputs, but whatever the processing logic you have been put, it's like that. It's never going to change. So that's what the aim of any of the general conventional programming is. When it comes to machine learning, the advantage you have compared with the conventional program is it actually reacts or it actually does something when it learns that something is not happening according to the expectation. That means every time it gives an output, it understands, it gets some kind of feedback mechanism where it understands, hey, I'm not supposed to do that. Let me learn and tune myself. So that's what happens. And that's the intelligence part of it, or I would say that's the induction learning part of it. So here, when you say machine, it does not mean just a robot or a device. It could be even your program also. If you can make a program learn by itself and do the predictions in a much, much better way over a period of time, then you can call those programs as machine learning programs. Okay, so basically, if I want to put a very high level, machine learning is the art of making your programs learn by itself. In fact, if we deep dive, there is one more thing it does. Actually, it does two steps. One is generalizing from the data so that it knows the patterns from it. And once it knows the patterns, that's where it starts predicting it. So that's the overall part of it. Now, in machine learning, if you see, there are basically multiple types of learning. I would say these are different paradigms or approaches of learning. I would call this as paradigms of learning, paradigms of machine learning. Different approaches, you could say. One is supervised, another is unsupervised, another is reinforcement learning. There is one more you might have seen in some books called semi-supervised learning. But this is not something you see very often. It is just a here and there kind of thing, supervised learning. Now, what is supervised learning? Okay, I said supervising, supervised learning. So what is supervised learning is? Supervised learning is as same as, let's say there is a class and whenever you do a mistake, the teacher is helping you to correct and you are learning the mistakes and improving yourself over a period of time. That's an exactly, that's a classical example or common example everybody puts up about supervised learning, which is exactly the case. Supervised learning is all about when given an input data and output data, it understands the pattern behind or the mapping behind that input. It is like identifying the pattern is what supervised learning it does. So it is like once it identifies the pattern, it generalizes it and it starts predicting. In the case of supervised learning, when you say label data, it means it knows what is the output going to be. So from that, it will learn. Now, where is the prediction part coming is once it is able to generalize and identify a pattern, whenever you give out input, which is similar to whatever it learned, then it can predict output because it already learned that patterns. Like let's say you have given a lot of cats faces or dogs faces to your program, and it has seen hundreds of cat faces and hundreds of dogs faces. It might have remembered some kind of pattern because it knows in the data, it is already given that when this face is there, this is a cat. When this face is there, this is a dog. So it understands the features based on the images. And finally, it come across one conclusion that whenever this kind of structure is there, or it has a tail, it has some whiskers and all. So some kind of pattern it derives, similar to how we recognize, right? So it learns it. And whenever you give a new cat altogether, which is like some different breed, it is able to at least say, hey, this looks like a cat or this looks like a dog. So that is what supervised learning is. So it identifies a pattern. From there, it starts predicting it. In the case of unsupervised learning, when I say input and output known here, I'm just putting in a very, very basic term, so it is easy for everyone. Here, input and output is also known. Output is what people call labeled. Here in this case, it knows only about input data. It doesn't know about output. That means you are telling go and do by yourself. It is as simple as self-learning. That means if I tell you, okay, you don't join any sessions, you don't join any courses, learn by yourself, you will figure out a way anyway, right? You will figure out a way and learn by yourself without going into any particular training or anything as such, right? That's unsupervised learning. I would say in general, it is nothing but a self-learning. So what happens in unsupervised learning is when you're given the data, from the data, it tries to identify the different patterns. From the data, it identifies different clusters like that. So again, unsupervised has different kind of things like clustering and association rule mining and all that. That is what unsupervised. At a high level, you can understand it is only given data. Output is not told to it. That means it doesn't know anything about its output. It has to identify that by itself. In the case of reinforcement learning, it is as simple as if I ask you to, let's say, for example, first time when you're riding a bicycle. Now, your parents or your uncle, somebody might have taught you how to ride a bicycle or a bike or anything or a car. Now, initially, we might be doing mistakes. We might not be able to do it the first time, right? First time itself, we're not able to do because that's the first, that's like we are learning, right? So you might be doing some mistakes. Sometimes you will be doing properly. Sometimes you will be doing mistake. That's exactly is reinforcement learning. Reinforcement learning is all on the field you learn. And whenever you actually do something, you will get an award, which is like saying, yeah, you're doing good. Whenever you do mistake, you will get a penalty, which is like saying, hey, you should not be doing like this. Maybe you should pedal the cycle like this, something like that. So it keeps learning over a period of time and understand that. That's called reinforcement learning. Now coming to semi-supervised is like a partially supervised learning, partially unsupervised. It's a mix of them both. Most of the semi-supervised learning, if I want to give an example, your Google Photos, you might have, most of you, I'm assuming you might be part of these Google Feeds and all. If you see, if you have subscribed to Google Photos, you might have seen that it starts putting buckets of photos of a particular person. And sometime it will ask saying, can you tell me who is this? Once you say that, it automatically identifies that person and puts up. So the knowledge, one thing here you understand is initially it is identifying the photos into or keeping the photos into different buckets by itself, which is where the unsupervised part comes. And you're doing a supervision at some point where it is asking, can you tell me who is this? You might be saying, this is my father, this is my uncle or whatever. So based on that, it will categorize and say, this is uncle, this is father and all. So that is your supervised. That means a partially very less amount supervision is there, but a lot of things is unsupervised. So that is one example of semi-supervised learning. Mostly it is unsupervised though. Now, why we are talking about it? We are talking about this. Now, where the confusion matrix comes is in supervised learning. So when I say these type of different learnings, each learning has actually got some set of algorithms, or I would say some set of programs under that. In supervised learning, there are two types of things. One is called regression. Another is called classification. Just like unsupervised also have something like clustering, association, rule mining. Reinforcement has something, semi-supervised has something. But since that is not the topic, we'll not go much because we understand at high level, which is sufficient for this particular session. Now in supervised, I said two types of approaches. I would say two types of supervised learning. One is regression, another is classification. The high level difference between these two is in regression, when you ask it to do something to identify a pattern and start predicting, the resultant or the way it predicts will be in terms of a continuous data, or I would say real numbers. That means it will give the data in terms of some numbers. It could be 0.25, 0.35, or 1, 2, 3, a set of numbers. Okay, that's called continuous data. In the case of classification, it is called, it actually gives the output, the prediction in terms of discrete data, or I would say discrete data in the other terms, a limited set of values, or even if I want to become more precise, I can say categorical data. This way, I can say this as a numerical data output, and this is categorical data. Categorical data means, you know, there will be, why I wrote the spelling, categorical. Yeah, categorical data. Numerical data means the output, the prediction will be in terms some form of numbers. Categorical data means the prediction will be in some form of limited values. A simple example of categorical data is, let's say in the class, if I ask how many people are working, how many people are students, here the two limited set of values is working, employees, or students. Those are the two set of values. Anybody will fall into either of these buckets, right? Somebody could be there who is not working, who is not student, they can fall into other bucket, right? So if you see, there are 3 set of limited values already coming in. Similarly, when you're traveling in a flight, you might get economy, premium economy, business, luxury. Those are again categorical data example. If you're traveling in train, different classes of train seats, first class, second class, third class, that is again categorical data, which means classification gives you an output in some set of categorical data. That's what classification does. And again, classification has different things altogether. Now, why we are talking about this classification in particular is this confusion matrix, which we are talking about, it is useful to assess this classification algorithms. That means you have classification algorithms. Like I said, in classification algorithm, you have, logistic regression as one algorithm. You have different algorithms that falls under this classification. In that, when that algorithm, how do you know whether it is doing the prediction correctly, or how do you evaluate its performance? So for that evaluation is what confusion matrix is used. So confusion matrix is basically for the classification algorithms only, and it can be done only when the output is known, or the you know the true values. What is going to be the true values, correct values? You should be knowing it. Then only this will be applied. So one of the learner, when they said like it will actually learn from the data set, that's correct, but it applies only for classification, not for anything, only classification. Okay, so that's where our confusion matrix comes. So you can say confusion matrix, or sometimes people call it as error matrix. It is more about evaluating the performance of the classification algorithms. That's what it means. Now, why it is important? Why we need to evaluate? I mean, we can just rely on the whatever the algorithm gives, right? First of all, the basic thing you have to understand is the machine learning algorithms are all predictions. Now, if you don't evaluate it, what could be the problem? So here the case is, a simple case could be, if let's say this doctor assessed this employee when they came for something like some fever or stomach pain, and doctor said, you're all right. He didn't check properly. And finally, he sees one day that doctor is admitting into hospital with a serious issue, which means what? The evaluation of patient is not really done properly, isn't it? The same problem applies to our algorithms also. If you don't evaluate, your predictions will give wrong results. That's why we need the confusion matrix in order to do the things correctly. In medical sector, it is like very crucial. So when you apply any of these algorithms in medical sector, you have to evaluate how good the model will do and all that thing. So, machine learning is everywhere these days. It's in medical, bioinformatics, e-commerce, everywhere. So it is very important when you use an algorithm, you have to be able to evaluate it, and particularly classification algorithms, if you want to evaluate, this is what we have. A confusion matrix basically looks like this. So your confusion matrix, what it identifies is it is like this is for a 2-class classification algorithm which produces 2 possible values. Something like, one example of classification algorithm is identifying an email as spam or not spam. Those are only 2 possibilities. Let's say I want to consider this as a classification problem and write some algorithm on it, where it does that classification of by looking at email and identify whether it's an email, good email, or a bad email, which is non-spam email. Now, if I want to do that, I can use this 2x2 table. So this 2x2 table is for the cases where you have the categorical data set with 2 values only. If you have 3, then you have to use 3x3. If you have 4, 4x4. So like that you can do. That comes under multi-class classification anyway. This is for a binary classification if you want to use. This is how the confusion matrix looks like. And these are all your predicted value, and these are actual value. And this is how we indicate true positive, false negative, true negative. I will tell what does exactly that mean by that true positive, false positive, and all that. So if you see before we talk about false positive and false negative, which is given here, true positive means we know that a patient has a heart disease, because we are talking about this problem, heart disease. We know the patient has a heart disease, which is the actual value from the observation. And your machine learning algorithm, the classification algorithm, also predicted same. Then you will call true positive. True negative means you know that that patient does not have a heart disease, and your algorithm also predicted, yes, that particular person does not have a heart disease. That is called true negative. That means both you as well as the machine learning algorithm also giving the same result. That case, either it could be positive, that means they have a heart disease, or they do not have a heart disease. Those 2 cases where your actual observation and prediction is seen. False negative and false positive is the dissimilarity. That means false negative case where patients have heart disease but classified as not heart disease by the machine learning model. False positive means patient does not have heart disease, but classified as having heart disease. That means whatever you are predicting, whatever you know, and whatever the machine learning predicting is not similar. It is different. In that case, these are the two possible things. That's what false negative and false positive is. Now, what is a confusion matrix? Like we already discussed, this is basically for a binary classification. So like I said, you can see that it is basically to evaluate classification algorithms, the one which I told you here, right? In the machine learning different paradigms, it is there to evaluate only classification algorithms, not for other type of algorithms. For the other type of algorithm, there are different channels altogether. Now, this is like actual. Instead of saying actual and predicted, they have put actual positive, actual negative. Now, let's see with this an example. Like, let's say, now, how do you know that? Like, let me give you the actual example. So if you see, this is the data. In this data set, assume this is the data set. There could be employees with different age, and you have work class, whether they are working in a private sector or government or public sector, something like that, and the gender, and number of hours they are working, and the salary they are getting, whether they are getting less than equal to 50, greater than 50, greater than equal to 50. This is the category. From this data set, when actually you want to assess whether this particular, whatever algorithm you apply in order for it to predict, how do you know that this algorithm is doing things correctly? And that's where we use classification, this confusion matrix. Now, what you can do in the confusion matrix is something like, let me show you. So this is still showing the same thing. Now, when you get a two table, and here you see, you are taking only two classes, two buckets, whether income is greater than 50K or less than equal to 50K. But if you say, I want to check income greater than 50K, income less than 50K, and income equal to 50K, then this 2 by 2 will not work. In that case, you have to put a 3 by 3 confusion matrix. It is as simple as if I ask you for two values, how many possibilities are there? You can say true, true. It's a simple truth table. If you actually look at, if for two classes, if I want to identify how many true and false values are there, there could be true and true, right? That is yes, yes, like that. There could be true, there could be false, there could be false, there could be true, there could be false and false. How many possibilities? 4. Similarly, for 3, you will get 9 possibilities. For 4, 16. So that many possibilities will be there. And based on the same theory here also, here people are considering just 2 classes. So for just 2 classes, how many possibilities will be there? It will be 4. If you say, I want to consider one more possibility, you need 3 by 3, not this. So this is what we are doing. Let me show you the actual numbers. So the actual number says, that means what we identified is, from this data, we are identified that 150 are, this is income greater than 50K. And this is both actual as well as predicted is this. And this is 120 is where, where this true positive, 150 having income greater than 50 and were correctly classified. Similarly, true negative, 120 not having greater than 50K and were correctly classified. And that means in this green one, both your actual as well as the prediction by model seems to be same. This is the dissimilarity part. This is what you get it. Now, what you do in order to assess? Now, again, false negative, false positive, both where you will have a dissimilarity. Now, this is what you derive. Now, how do you know this is correct? Like, we know we have put a for two classes, we have put a confusion matrix. Now, how do you actually know this is correct or wrong, or should we go with this result or not? That's where these metrics help. So we have these metrics called accuracy, precision, recall, and F1 score. So accuracy tells you what is your proportion of total number of predictions that are correct. So basically the formula, if you look at it is nothing but how many true positive, true negative, which means how many times both you and machine learning model also said correct, give correct values. That means there is no dissimilarity. That divided by all the different possibilities. That means this case and this case, both what we observed and what the machine learning model or the program is saying is correct. That divided by this will give you the accuracy. So something like it will come to 90%. So it says 270 divided by the total values. It's just count of it. And all the values if you count, that is the sum of all the possible values. And 150 plus 120 is where both you and the ML model also gave the correct answers. I mean, your answers are same. So that means the accuracy is 90%. This is one thing. So this just says, if you look at deeply, this just says, you're just saying both the accuracy of the observation you have observed based and the machine learning model observed is 90% of the time it is correct. That's what you're saying. So it is just to measure the performance of the model if I want to put in a simpler way. Now the other things to say what we have done is correct or wrong is precision. Precision is nothing but a measure of how accurate your model positive predictions are. That means when you're saying, hey, my model does this every time correctly, what is the accuracy of it? What is the precision of it is what actually you're trying to derive. In this case, if you see, we are just doing true positive divided by true positive plus false positive. That means this and this 150 by 150 plus this. This should be, yeah. So 150 plus this and this. So this gives the precision. That means it says how many times, what is the proportion of the correct positive predictions can happen with the algorithm you have used. So it says 93%. Similarly, when you see recall just tells you the effectiveness of your classification model in identifying all relative instances from a data set. It is nothing but the ratio of number of true positive instances divided by the sum of true positive and false negative. It is just trying to identify how many number of true positives can happen. That's what recall is. And this is 88%. And similarly, F1 score. This F1 score is basically to evaluate the overall performance of your classification model. It is nothing but a harmonic mean. If you guys are from statistic background, it is nothing but a harmonic mean of precision and recall. So you can see the formula, it is the harmonic mean formula, just that we are applying on the precision and recall. Now, using all these measures, you actually take a decision saying whether I should go for this or not. Okay, so it is like once you actually set up a confusion matrix, and by the way, you don't need to do all this. If you know about package called SciPy, SciPy already have something called a metrics package. Using metrics package, it automatically generates all this confusion matrix, all this metrics also. But it is important that you have to understand the meaning of each of it. That's the overall theory. Now, the thing is, this is only for two class. That means only for two possible values. If there are more than two possible values, how do you assess? The measure, whatever the measures we are doing or whatever the metrics we are using, that's going to still be same, but it will be one more combination you will get. That means a 3x3 or a 4x4, depending on the number of classes you choose. But overall, the metrics measurement is going to be the same, irrespective of how many classes you want to assess. Now, this is for multi-class. Like I was saying, right? Till now, what we did is this is called a binary class. Binary class means only two possible values. You can see income greater than 50K, income less than equal to 50K. Two possibilities. If you are saying beyond than that, then it is called as a multi-class classification. So for that multi-class, how you do actually do a confusion matrix. So if you see, these are the three possible classes. Three possible classes means, like I said, it's a 3x3. 3x3 means 9 possible values. You can see 9 possible values in this case. Actual, predicted. And from here, again, the same formula, whatever you have used, the accuracy, precision, recall, F1 score, you will use all that in order to derive whether this is something we can rely upon or not. The metrics wise, it's not going to change. Just that the confusion matrix, the way you put up will change because the number of classes increases. So these are these true positive and all. And finally, your accuracy is this, which is 80%. And this is precision, which is 68%. Compared to compared to binary class, if you look at the accuracy as well as precision is relatively lesser here. Their accuracy is 90%. Here accuracy for a multi-class is 80%. And again, if you see the precision also, it is relatively lesser. It is like 68%. And recall is 95%. So what do we understand overall from this confusion matrix? So one thing is, it is nothing but an assessment. Basically, it is just, assessing whether your model do good or not by putting up a confusion matrix and finally using some matrix like accuracy, precision, recall, and F1 class to see whether we can go with that result of whatever the ML model gives or not. That is what we will identify. And those are all statistical measures. So that is what the evaluation talks about. And even it works for imbalanced data set. That means, when the data is not proper enough, so you can use confusion matrix also to evaluate it. And you can use the precision and recall to identify the correct predictions, because if you see in both the cases, we are trying to identify the proportion of positives. And this can be used not only for binary class. As you can see, we have applied both for binary and multi-class classification also.
Binary means 2, multiclass means more than 2. So you can apply confusion matrix for both of them. Just that when multiclass more and more classes comes up, so you need to get a confusion matrix accordingly. Binary classification is relatively easy, comparatively easy. So that's all I have. I hope at least you get a gist of what is confusion matrix and where it is used, and how do we derive whether it is good or bad based on the 4 measurements we have discussed. So apart from this, there is other evaluation metrics which can be used as something like, which is called ROC curve. You can even use that, and null error rate. Those also can be used. This is not just the one, but this is one thing which is quite popular enough. And there is something called the one which is very popular related to similar to confusion matrix is called class prediction error, where that shows both the support and the difference between actual and predicted classes. There is another thing called discrimination threshold, where it shows the precision, recall, Q1 rate, overall rate for binary classification that uses this discrimination probability or a score. And in case you are interested in, let's say, you want to know about what are the courses which are related to data science we have something like, which we skipped in the beginning, which is more of a data science plus ML combo. And I would say it has something on Python also to just give you some kind of a refreshment. So this particular course actually is a combination of data science, Python programming, and machine learning. The first 2 modules are primarily on data science, and from first three, and from 4th is where we start teaching about data science, particularly NumPy, Pandas, and Matplotlib, and 5th as well. Then from 6th, we start teaching you about machine learning. And again, like the different paradigms, like I said, right? Supervised, unsupervised, all that. So all these will be taught in detail. So this is the course. And if you want, you can check with our support team to understand more details. But this is one thing we have, which actually covers both programming, Python programming, machine learning, and data science. Okay, thanks. Thank you all. Thanks for your time. See you. Bye.